Alright, so this video I'm going to really help you with um, Math 301, which is the multivariable calculus. So I want you to keenly follow. All right. Okay, so we start with vectors, and to start with vectors, we need to understand that vectors, a vector is a quantity, it's any quantity which has both magnitude and direction. So you have both magnitude and direction. So example is displacement. We can talk about acceleration. We can talk about weight. We can talk about velocity. We can talk about force. When it comes to a scalar quantity has only magnitude, but no direction. An example, we have time, we have speed, we have mass, we have area, we have pressure. Okay. So if you want to denote vectors, we normally use block letters. Like, for example, if I write AB with a vector like this means that the movement is starting from A, moving to what? To B. Other books also can write a vector and put something beneath it. Others also can write A and just put an arrow on top. We need to also understand that vectors can be written either in a column vector form like this, or it can be written in a coordinate form like this. Where this is the magnitude and this is the direction. All right. So quickly, we move on to the magnitude. Magnitude. So let's quickly look at magnitude, or the length of vectors. Magnitude or length of vectors. Before we go to magnitude and length of vectors, you need to ensure that you follow keenly what we are explaining so that you'll be able to understand. So if I write, for example, 2, -3, this 2, -3 in vector in a standard basis form is the same as 2i minus 3j. This I means that it's moving in the x direction, and the j means that it's moving in the y direction. If it is 3, then we say I, j, k, which means it is now in a 3-dimensional plane where it moves in x direction, y direction, and the z direction. Okay. So with that, here becomes y, here gives you your x, and here gives you your z. So take note of that. So when I give you 3i plus 4j, it means the vector is actually 3, 4. Okay, so take note of that. Having said that, anytime you are told to find the magnitude, what you need to do is to quote your formula and just substitute. And so understand that magnitude of a vector is the same as the length, the same as the modulus, the same as the distance. They all mean the same thing. Or in other words, an absolute form like this. All right. So if I have a point, say x1, y1, I have another point here, say b, x2, y2, then the magnitude of these 2 points will be your x2 minus your x1 squared, your y2 minus your y1 squared. And so if you are giving A to be 2, 4, and B to be 6, 4, or 6, this is 6, 8, you have to find the distance of AB. All that you need to do is to consider this as your x1, y1, x2, y2. Then you just substitute into the formula. Our x2 over here is 6 minus our x1 here is 2 squared plus our y2 here is 8 minus our y1 here is 4 all squared. Okay. So you realize that 6 minus 2 gives you 4 is squared. 8 minus 4 gives you 4 is squared. And 4 squared is 16. And 16 plus 16 gives you 32. And that 32 can be broken down into 16 times 2, which is the same as 4 root 2. So this is how we solve for magnitude. Another thing also you can get from this is, if I give you, for example, AB, and your vector AB happens to be xy, and you are told to find the magnitude for this, it gives you x squared just plus y squared. And so if I say AB, okay, the vector is 2, 3, then the magnitude of this AB will be square root of 2 squared plus 3 squared, and 2 squared is 4, 3 squared is 9, giving you square root of 13. And anytime you finish solving magnitude, you add units to it. Another thing also is, if I said you should find, for example, find the magnitude of AB equal to minus 5i plus 10j. So this vectors here is actually the same as writing it as in a component form, minus 5, 10. And you have to find the magnitude of this. The formula, as we said, is x squared plus y squared. So this is going to give you negative 5 squared plus 10 squared. And negative 5 squared is 25. And 10 squared is 100. So this gives you square root of 125. And you now break it down and you add your unit to it. So this is how we solve magnitude. Another example on the magnitude, if I give you V is equal to 2i plus 3j plus 6k, the magnitude of this V, since it is ijk, it means that the magnitude will be x squared plus y squared plus z squared. And so this is going to be give you 2 squared plus 3 squared, then plus 6 squared. So 2 squared gives us 4, 3 squared 9, and 6 squared 36. And so 4 plus 9 plus 36 gives you 49. And square root of 49 gives you 7. And that gives you 7 units. So basically, this is how we solve magnitude. We now move on to unit vector. So a unit vector is one which has magnitude of 1. So if the magnitude has magnitude of 1 and is often indicated by putting a hat on top of the vector. So a unit vector has a magnitude of 1 and is denoted by a cap. And so for the unit vector, if you move in the x direction, once again it's I for x direction, and it's j for y direction, and it is k for z direction. And so when it comes to unit vector, the formula simply for a unit vector is your a cap is equal to your vector a divided by the magnitude of your vector a. Take note of that. So this is the unit vector formula. So a cap is equal to the magnitude at the denominator, then the vector at the numerator. And so let's take an example and understand this unit vector. We are actually given a vector to be 5i plus 12j. As I said, if you are given a vector like this, this is actually the same as 5, 12, okay? And so we said a unit vector, which is a cap, is your vector divided by the magnitude of the vector. So it presupposes that I need to find the magnitude of this particular vector. And the magnitude of this vector is your square root of x squared plus y squared. So our x is 5 and our y is 12. So 5 squared is 25 and 12 squared is 144. So this will give you 169. And square root of 169 is 13. And so coming back to the unit vector, we said it is your vector, okay? It's your vector for the magnitude was 13. And so to solve them individually, this means 5 upon 13, I plus 12 on 13, j. What it means is you are taking each of them over the denominator. Okay. And don't forget this one belongs for I, and this one is for j, as it was given. So that's how we solve a unit vector. Let's take another question for better understanding. Question says, given that your vector A is 2i minus j plus 2k, and your B is minus I plus j minus k, and we have to find a unit vector in the direction of C where C is your A plus your beta A plus beta B. So if you look at this question, we have to solve for, we have been given beta A and beta B, and we have to solve for the unit vector, the direction where C is equal to your beta A plus beta B. So my C, which is equal to your beta A plus beta B, we know that beta A simply means, okay, my C is A plus beta B. And we know our beta A is 2 minus 1, 2 from here. Just take the coefficients, okay? Plus, what's my beta B? My beta B is minus 1, 1, and minus 1. So, we're going to add them component-wise. So, 2 plus minus 1 is 1. 1 plus minus 1 is 0. Then 2 plus minus 1 is 1. But don't forget that we have to find a unit vector, and the unit vector is my C cap is equal to the vector over the magnitude of the vector. So I need to now go and find the magnitude of this vector, because already we have found our C, but we need to go and find the magnitude of C. So this is what we have here as your C. So to find the magnitude of C, this is going to be x squared plus y squared plus k squared, which is the same as 1 squared plus 0 squared plus 1 squared. So 1 squared plus 1 giving you square root of 2. So our C cap is our vector divided by the magnitude is square root of 2. So this one means that this divided by this so it means we have 1 on root 2. Okay. We also have 0 on root 2. We also have 1 on root 2. But radical cannot be at the denominator. So we need to rationalize. And this will give root 2 on 2. I. For 0, we know that 0 divided by any number is 0. So the j component is 0. And the k component is also root 2 on 2. Remember that since radical cannot be at the denominator, we need to rationalize. So we multiply the numerator and the denominator by root 2. 1 times root 2 is root 2. And root 2 times root 2 is 2. So that's what gave us what we have here. Okay. So you can finally say we have root 2 on 2i. 0 times j is 0 plus root 2 on 2k. So basically, this is how we solve unit vector questions. This is how we solve unit vector questions. All right. We now move on to addition and subtraction of vectors. So for that, if I have my A to be x1i, y1j, and my B to be x2i, y2j, this simply means that if I want to find my A plus B, the x will add up and the y will also add up. So what it means is if I have A, for example, to be 2I plus 3J, and I have B to be 4I plus 5J. If I want to find A plus B, A plus B simply means that 2 plus 4 and 3 plus 5, component-wise. You add them component-wise. All the I together and the J together. So 2 plus 4 is 6, and 3 plus 5 is 8. If it is subtraction, it's going to be 2 minus 4 and 3 minus 5, which eventually will give you -2, -2. Don't forget this can be written as 6I plus 8J, and this also can be written as -2I minus 2J. So basically that's how we add and subtract vectors. Having said this, we now move on to dot product. So when we come to dot product simply means dot product is just an algebraic operation, okay? That takes two vectors. It's an algebraic operation that takes two vectors. Then it will return. It returns a single number. So it's an algebraic operation that takes two vectors and returns a single number. And that single number happens to be scalar. Okay. So what it actually means is if I have A to be A1, A2, A3, all the way to AN. Now B to be B1, B2, B3, all the way to Bn. If I want to find A dot B, what it means is your A1 will multiply your B1 plus your A2 will multiply your B2 plus your A3 will multiply your B3 all the way to AN multiply your Bn. This is simply a dot product. Let's take a practical example and you will understand it better. So what it means is if I have P, beta P, to be 2I plus J minus K, and beta Q to be I minus 3J plus 2K. And we also have beta R to be 5I plus 2K, which means the J is 0 since they did not bring it. Then the first question says you have to find the dot product of P of beta P and Q, dot product of beta P and R, and I'll leave you to solve beta Q and R, the dot product of that. So let me solve the first two. So to find the dot product of P and Q, don't forget this beta PQ can be written as 2, 1, minus 1, okay? Then our Q can be written as 1 minus 3, 2. So our P and Q is going to give us 2 times 1 plus 1 times negative 3 plus minus 1 times 2. So this gives us 2 minus 3 minus 2. Don't forget we said that when you find a dot product, it leaves an answer to be scalar. So 2 minus 3 minus 2 will give you negative 3. So the final answer is a scalar, which is negative 3. The second question says our vector P dot beta R. So we have 2, 1 minus 1, dotting 5. For easy understanding, the J component did not come, so put 0 here. Then the K is 2. So don't forget we are going to dot product. So 2 times 5, this will multiply this, okay? Plus this will multiply this. 1 times 0 plus this will multiply this. Negative 1 times 2. So this eventually will give you 10 plus 0 minus 2. And eventually this will give you 8 because 10 minus 2 is 8. So basically that's how dot product is. It's not difficult at all. So let's take some, let me give you another question on that before I go into more details. Find the dot product of vectors A to be 1, 2, 3, and B to be 4, 5, 6. So once again, the dot product of A and B, which is your 1, 2, 3, will be 1 times 4 component wise, okay, plus 2 times 5 plus 3 times 6. So 1 times 4 will give you 4. 2 times 5 is 10. And 3 times 6 is 18. So 10, 28 plus this gives you 32. So two vectors, the dot product eventually giving us a scalar to be 32. So you take notes of that. All right. So take note of this. The scalar or the dot product. So the dot product is still the same as the scalar product of two non-zero vectors A and B is defined as A dot B equal to A times your B cos your angle, where this theta is the angle between A and B. Take note of that. So your dot product is equal to this, where this theta is the angle between A and B. So we said that if theta is 0 or pi, don't forget this theta is between 0 and pi, okay? So if the theta is equal to 0 or pi, then we say that they are parallel. And if they are parallel, if theta is equal to 0, then the dot product is just equal to the magnitude of A times the magnitude of B. If your theta is equal to pi, then your dot product is minus the magnitude of A and the magnitude of B. So you take note of that. However, if it is perpendicular or otherwise orthogonal, then your dot product will be equal to 0. Because in that case, your theta is 90. And cos 90 will give you 0. And 0 times any magnitude here is 0. So eventually, your dot product should be equal to 0 if it is perpendicular. But if it is parallel, this is what it is. All right. Now, if you are to form an angle formed between two vectors, then your theta will be the cos inverse of the product of those vectors divided by the magnitude of those vectors. So you take note of that. Having understood this, let's take an example. So if the magnitude of A and B are 7 and 5 units, respectively, and the angle between A, beta A and beta B is pi on 3. Find beta A, dot product of beta A and beta B. So the dot product of beta A and beta B, knowing fully that an angle is given, is the beta A, the magnitude of beta A times the magnitude of beta B, cos theta. The magnitude of A is given to be 7. Times the magnitude of B is given to be 5. Then cos the angle is also given to be pi on 3. So 7 times 5 is 35. Cos pi on 3, we know that pi is 180. 180 divided by 3 is 60. Cos 60 is half. And 35 times half is 35 on 2. So that's how we solve for the dot product when an angle is given. All right. So let's take another question. Find the angle between beta P and Q if your beta P is given as this and beta Q is given as this. So you have to find the angle. Don't forget that. So your cos theta, you know, is the dot product of your P and your Q divided by both of them's magnitude. So we need to find a dot product first. So the dot product of P and Q is going to be 1 times 3. We have treated it already. Negative 2 times negative 2. 3 times 1. So there is 3 plus 4 plus 3. And that eventually gives you 10. The magnitude of P will be the square root of x squared plus y squared plus z squared. Okay? So 1 squared plus negative 2 squared plus 3 squared gives you square root of 13. Then square root of 14 instead. Sorry. Then a magnitude of Q using a formula which is x squared plus y squared plus z squared will also give you 9. I think this is also given as the same 14. So to substitute into the formula here, your cos theta will be the dot product we got 10 divided by square root of 14 times square root of 14. And square root of 14 times square root of 14 is 14. So 2 into 10 is 5 and 2 into 14 is 7. So theta will be the cos inverse of 5 on 7. And with your calculator, you will be able to get an answer. Okay, let's move on to another question. Question says find x such that vertex A, which is 2x, and B, 3, 4, are orthogonal. So when you mention orthogonal, it means that the dot product is 0. And if the dot product is 0, it means that our A, which is 2x, our B, which is 3, 4, should be equal to 0. So you have 2 times 3 plus x times 4 equal to 0. So this 6 plus 4x equal to 0. We make x the subject. When the 6 cross returns negative 6, we divide through by 4. And our x is negative 3 on 2. All that you need to note is that what? If it is orthogonal, your A dot B is equal to 0. I hope it is clear. So with this, you should be able to solve examples on your own. All right. Another question. Another question is saying that a triangle has vertices 0, 0, Q to be 4, 2, and R to be negative 6, 2. You have to find the value of QOR. So what it means is, for example, if there's a triangle O which means from the origin 0, 0, Q, which is 4, 2, and R, which is 6, negative 2. And we have to find angle Q0R, QOR, which means that the concentration is here. So basically, this means you are looking for an angle between two vectors. So with this, it means that we let theta go to angle QOR, okay? Then the dot product of OQ and OR, the dot product of OQ and OR will be your OQ times your OR cos theta, okay? So our Q, don't forget our Q is 4, 2, and our R is 6 minus 2. So the dot product of this OQ and OR, okay, will be 4 times 6, 2 times minus 2. So 4 times 6 is 24. 2, this is minus 4, which gives you 20. Okay. So now the magnitude of OQ is 4 squared plus 2 squared, which 4 squared is 16. 2 squared is 4, giving you square root of 20. Okay. Then your OR formula also will be 6 squared plus minus 2 squared, which is 36 plus 4, giving you square root of 40. You can choose to break this one down to 4 root 5. And this one has 4 root 10. So put it inside the formula here. Our dot product here. Our dot product here gave us 20. So we have 20 equal to our magnitude is 20 for OQ, and OR also is root 40. Then cos theta. Okay. So root 20 times root 40 gives you root 800 cos theta. So this is same as cos theta equal to 20 divided by root 800. So now 20 divided by this root 800 is the same as 20 root 2. So when this one cancels, you're left with 1 over root 2, and cos theta is the same as square root of 2 on 2, rationalizing it, which I've taught you already. So theta, which is the angle between the two vectors, will be the cos inverse of root 2 over 2, which is 45 degrees. So therefore, the angle between the two vectors is 45 degrees. All right. So basically, this is how we solve questions on vectors so far where we are. Okay. We now come to another portion called equal vectors. So for equal vectors, what it simply means is that we say two vectors are said to be equal if they have the same magnitude. And direction. So for example, if I have A to be x1, y1, and B to be x2, y2, and I say A and B are equal, it means that the magnitude should be equal. And they have the same direction, which means that if A is going this way, B also is going like that. To solve an example on this, if I have P to be A plus 3, B minus 1, and Q to be minus 2, 3, then if the question says find A and B, if P is equal to Q, it means that my P, which is A plus 3, B minus 1, will be equated to minus 2, 3. Then what you need to do is to equate them component-wise. So A plus 3 equal to negative 2. A will be equal to negative 2 minus 3 is negative 5. Likewise, equate the component-wise. B minus 1 equal to 3. B is equal to 3 plus 1 is 4. So therefore, A is minus 5 and B is 4. So that's how we solve questions on equality of vectors, which is equal vectors. Okay. So with this, we need to spend time solve questions on the practice questions that has been given. All right.